Okay, let's talk about some of the non-linear relationships that can exist geometrically. If you're throwing a ball or kicking a footy or shooting a cannon, if you were to trace out the path that the projectile or whatever it is that you're throwing travels through the sky, you will see these long, curvy lines as gravity works on it and pulls it back down. It has a special name, that shape. It's called a parabola. Parabolas can be shown mathematically by using this formula here. Y is equal to x squared. This is the form that they generally will take. If you've got a y value and an x value, and the x value is being squared, you will end up with a parabola. There's actually some different types of parabolas. We can reflect them about their turning point. You can have a parabola like this one here, which is kind of like, I don't know, like a bowl. That's with a positive value of x, and it can be reflected across the turning point. If you've got a negative value of x, you end up with this upside down one. When the turning point is the smallest number, we call that a minimum turning point. When the turning point is the highest, it's the maximum turning point. I actually have a little Desmos screen that I will show you here. You can see up here, I can't really make it bigger, but I have our y is equal to x squared, but I have this a. A is just the coefficient of this x, and I can give a different values. So when I give it positive values, you will see that we have that bowl shape. Okay. Now, the bigger the value, the tighter, the steeper the edges of that bowl shape kind of get. What happens is when I get closer to zero, that bowl will start to flatten right out. If I could get even smaller values, if I force it to be a smaller value, there you go, you'll see that it's very, very shallow now. Okay, so I'll go back to this, and if I go into my negative values, you will see that we've gone from a minimum turning point to a maximum turning point. Okay, so we can almost flap like the wings of a bird. Isn't that pretty? We can also, in our parabolas, we can change the translation. We can translate these things. Vertical translation, for example. If we go back to our Desmos, we can add. If we just do plus C and put in a slider for this C value, as we change our value of C, you will see that it changes where it crosses the x-axis, the y-axis. Okay. If it is positive number, it's up above into the positive numbers, and if, believe it or not, if it's a negative number, it goes down into the negatives. Isn't that something? And if we press play on both of them, you can see that, oh, it's flown off the screen. It'll come back. There it is. Oh, it's flown off the screen. Anyway, that's just, yeah. So that's our translation. We can vertically translate it. We can also do other translation. That's the up and down translation, but we can also do the horizontal translation, side to side. So if we put our plus C or minus C in brackets and have that then squared, well, you'll see that we will be able to get rid of that there. Oh, no, I need the plus. There's the C, and then we put it to the power of 2. If we move our C value now, I'll make this a little less steep, but you can see that our C value moves it horizontally, back and forward. Okay, so once again, parabolas, we've got horizontal translation, we have a vertical translation. They also can be reflected around their turning point. That's parabolas. Okay, next type of non-linear equation we'll talk about are ones called hyperbolas. Now, hyperbolas have the form of y is equal to 1 over x. So let's have a look at what we can make it do in Desmos. And we shall get rid of these ones. And we shall say y is equal to 1 over x. Well, there you go. So that is our hyperbola. That shape, as it curves around, this is a non-continuous, non-linear graph. Okay, you can see that, yeah, you can't draw this graph with a single solid line. You'd have to lift your pen. Okay. Again, these can be moved around. All right, if I made this just my C value, I could shift this hyperbole up and down, right, move it around. If I put a coefficient at the front here of this, oh, where's my mouse moving to? Here it is. You can see we can change the way the hyperbola works, and in fact it almost looks like it touches. It wouldn't have a vertical component though, because x would be, k is 0, so our x value would be 0. We're only getting a y value there, but you can see that we can change the way that this works. I'm actually going to make this c value back to 0 to show you a really important thing. If you'll note, please, in the only time that our hyperbola ever touches the actual x-axis is when k is 0. When k is 0 and it's forced to be into a straight line, it then does touch that x-axis. But for any other value of k, it doesn't actually touch the x-axis. It's actually referred to as an asymptote. And if I was to zoom in, I think I can zoom in here. Yeah, if I zoom in, oh no, I zoomed out. Zoom in over here, and you will see that that line gets real close to our x-axis. And it looks like, oh, look there, it's almost touching. Surely it's touching there. If I zoom in again, oh, no, it doesn't touch. And it will never touch. This asymptote, which is spelt like this on the screen there, that the asymptote is, in this instance, is where y is equal to 0, and it will never touch. It can go to infinity and it won't ever touch. And that's our hyperbola. Okay, next one that we want to have a quick talk about is the circle. Now, circles in geometry are based on this idea that if you were to trace a triangle, well, here, look, let me just show you the picture. If we were to draw a triangle on our little circle that we have here, I'll do it in blue. I'll start it at 0 and I'll draw it out to here. Why not? That'll do. Oh, now I made it go wonky. Try it again. Draw it out to about here. And then if I draw straight up, I will hit the outside edge of where this circle would go. So if I draw that back down to the middle, oh, it doesn't like that. It keeps wanting to snap to another spot. That'll do. You'll see I have my A here, my X value. I have my B, which is my vertical side there. And this bit here, the C, well, we have talked about Pythagoras in these videos recently anyway. So I could always find out my value of C based on my lengths of A and B. So using this Pythagoras theorem, which is right here, if I change those pronumerals into talking more specifically about my geometry terms, then we can see what a circle really is. So my A, if I change that to my X and my Y and my C into the R, which is the radius of the circle, imagine if I could make this triangle, if I could grab this corner of it and just sort of draw around the edge, I would be able to make this triangle change and it would be able to move all the way around. And so really it's based on this Pythagoras' theorem that we have our circle rule. Here it is here. Let's get old Desmos up and I'll show you, I'll make a circle in here. All right, so let's get rid of this asymptote and hyperbola, and we will say that x minus h to the power of 2 plus y minus k to the power of 2 will be equal to r squared. All right, so if I have sliders for all of them, now I need to reset my my good old my viewpoint of Desmos here. So you will see that I have got this tiny little circle here. It's now appeared. Now the reason why it's very little is because my values of h and my value of k and my value of r is 1. I could make that circle bigger by changing the radius value. So if I make the radius bigger, well, my circle gets bigger because the distance from the center of the circle to the edge gets longer. Okay, very good. I'll just leave it at about 2. That'll be a decent enough size that you can see. If I change and if you look up here, I've got my x minus h. So you might think that that will change. Oh, and look, it does. It changes our horizontal positioning. If I change that x value, it will change the center of my circle in the horizontal motion. The k will change it in a vertical motion. Okay? And of course, I already talked about the r. But what about my initial one that I said? If I had x squared, oh, that went down, x squared plus y squared equals r, on the lowercase r squared, well, we get a different kind of circle. I'm going to turn this one off. This circle here, doesn't matter what we do to these values of h and k because there's no h and k in this particular equation. And our circle then is locked on the origin. The center of the circle will be 0, 0 at this point, right there. So 0, 0, but the radius will still make the circle get bigger or smaller. What's interesting with this radial value, if you make it negative, it just gets bigger anyway, because we're squaring that, and a negative number squared is still just a positive number anyway. Okay, so that's all about our non-linear relationships, non-linear equations. Parabolas, which was one like this, y is equal to x squared, there's our parabola. We had hyperbolas, where y is equal to 1 over x. And there we have all of our wonderful different non-linear relationships that we need to be aware of. Okay, that'll do.